In this video we will be reviewing implicit differentiation as well as how to find the equation of a tangent line. Again, this is what this stands for, is write the equation of the line tangent to this function at x equals -1. Now, to do this, the first thing we're going to have to identify is that we are looking for y minus y1 equals to m times x minus x1. Well, in this problem we are given x equals -1, so we have x1. We still need y1 and we need m. So the reason why every time we look at write the equation of the line tangent to in these equations, the reason why we take the derivative is to find that slope. So I'm going to go ahead and write down this question over again, x equals to -1. And now all we're going to do here is we're going to go ahead and take the derivative of this, and this as it is. So the derivative of x squared, again, it's d dx of this entire side, x squared minus d dx of xy equals d dx of y squared and minus d dx of 5. Doing the easier parts first, the derivative of x squared is simply 2x. The derivative of a constant is simply 0. Make sure we don't forget to carry down those negative symbols where they belong. I'm going to also carry down that equal sign. The last thing we need to do is deal with this one and this one. So the derivative of y squared behaves again just like the derivative of x squared. But when I take the derivative of y squared, I get 2 times y to the power of 1. And then don't forget that we need to take the derivative of the inside. Now the derivative of x in respect to x is 1, so there would be a 1 here in technicality. Over here, the derivative of y in respect to x is dy dx, which is why, again, every time you take the derivative of y in respect to x, you get dy dx. So our last piece here is this thing, x times y. Now when taking the derivative of x times y, we have to remember that because of the multiplication between the two pieces, it's a product rule. So very quickly I'm going to go ahead and throw brackets here, and then I'm going to take the derivative of x, which is 1, leaving the second function left unchanged, y, and then plus the derivative of the second function, dy dx, times the first, unchanged. So again, if you need to see that, my f is x, my f prime is 1, my g is y, and my g prime is dy dx. And again, it would be these two pieces multiplied together, so 1 times y, and then f times g prime, which is again x times dy dx. So this is my derivative function. Again, I need to find out what m is, and m, remember, is always going to generally end up being dy dx at a given point, at x comma y. So I need to figure out, okay, what dy dx is. So I'm going to get all my dy dx's to one side. I'm going to simplify. So this is going to give me 2x minus y minus dy dx times x equals to 2y dy dx. I will add this term over because that will simplify all the steps. It will also be the most efficient way to do this problem. Okay, adding this term over, leaving these two terms alone, so that provides me with 2x minus y equals to 2y dy dx plus dy dx times x. Out of these two terms right here, I can factor out dy dx, so I'll end up with dy dx times 2y plus x equals to this 2x minus y, and therefore dy dx is equal to 2x minus y divided by 2y plus x. Now, if all I asked you to do was find me the derivative of this function, you would be done. This would be the end of that problem. This is not what the question asked. The question asked you to find the tangent line at this given point. So in that case, I need to be able to plug in x and y. Again, I am not allowed to substitute in m as anything other than just a number. Again, m must be a number. So I can't substitute this in. I have to take this x equals -1 and plug it in. At the same time, I need to go ahead and make sure that I have a y value, but this function does not do well for figuring that out. So off to the side here, I'm going to go ahead and I'm going to plug -1, this -1, into this equation. So I'm going to have -1 squared minus a -1 times y equals y squared minus 5. I'm going to solve this equation, in which case I'm going to have a positive 1 plus y equals y squared minus 5. I will subtract the 1 and I will subtract y, providing me with 0 equals y squared minus y minus 6. which does well for us because we can actually easily factor this into y minus 3 and y plus 2, which provides me with y equals 3 or y equals negative 2. So now you think that, well, which one do I pick? It's not which one do I pick. It asked me to write the equation of the tangent line at x equals negative 1. In a graph that looks like this, you would actually end up finding that there is more than one line at x equals negative 1. This doesn't have to be a function. It's an equation. It has a graph, and the graph is not necessarily passing the vertical line test. There can be two locations for x equaling to negative 1 where we have a y value. So what I'm going to do is I'm going to identify that my negative 1x value and my 3 is a y value. That's a point. And then my other point is negative 1 comma negative 2. So here, for this first piece, I'm going to go ahead and plug negative 1, 3 into this equation and get me a slope. In that case, it's going to be 2 times negative 1 minus 3 divided by 2 times 3 minus 1. In which case, I'm going to have a negative 2 minus 3 is negative 5. Divided by 6 minus 1 is a 5, giving me a negative 1 slope. So now I have x comma y and m. I'm going to go ahead and do the same thing with this one right here. Again, I'm just simply going to plug in negative 1 comma negative 2 into this formula over here. That's going to provide me with a 2 times a negative 1 minus a negative 2 divided by 2 times a negative 2 minus a 1. In which case, here I have 2 times negative 1 is negative 2 minus a negative, which means I'm going to add, so the top is actually going to be 0. Again, one more time just to make sure, that's a negative 2 plus 2. 0 on top. Let's make sure the bottom is not also 0. That's going to be a negative 5. In which case, my slope is then 0. So, I have two different slopes and I have two different points. Remember, all we're doing is we're plugging them to y minus y1 equals to m times x minus x1. So if I were to plug this one in first, I'm going to have y minus 3 equals m is negative 1 times x minus a negative 1. This provides me with y minus 3 equals to negative 1 times x plus 1. And again, we can leave that right there. Sorry. Again, I'm going to simplify this piece here, make it a positive, and I'm just going to clean that up just a little bit. And that's one of the equations that are tangent at that x value. And then when I plug in 0 for your slope and negative 1 and negative 2 for your y values, you end up with the second equation, y minus a negative 2 equals to 0 times x minus a negative 1. But since 0 times any of this stuff is always just 0, you're left with y equals, this is a positive 2, so I'll subtract it over to get negative 2. And those are the two equations that are tangent at x equals negative 1 on this function.